Good morning, everyone, and welcome to Automation Alley's webinar this morning, hosted by 3 Your Mind. My name is Allison Trumbull, and I am the sales manager here at Automation Alley. If you aren't familiar, Automation Alley is a World Economic Forum Advanced Manufacturing Hub, or AmHub, and we are Michigan's Industry 4.0 Knowledge Center. So basically, we host a plethora of events and obtain content from every aspect of Industry 4.0 to really give businesses a competitive advantage by helping them along every single step of their transformation journey. So here we obsess over disruptive technologies like blockchain, 3D printing, the Internet of Things. And our goal is to really work hard to make these really big complex concepts a little bit easier to understand in bite-sized pieces. So for example, some of the events we have coming up in person, March 17th here at Automation Alley in Troy, we have cybersecurity and the latest trends in industrial espionage. So we will have a representative, Ben Simon from the FBI to come in and talk about what's going on with cybersecurity, how you can keep yourself protected. As well, our big Industry 4.0 conference is going to be May 10th. So we have changed that date, and it's going to be hybrid, so in person as well as virtual at the Suburban Collection Showplace. So if you have any questions about participating, sponsoring, exhibiting, attending, please let me know. And don't forget, with that conference, all Michigan manufacturers do receive one free ticket. So feel free to reach out to us if you have any questions. You can also find that information online. But now on to our host company. 3 Your Mind is a Michigan-based leading additive manufacturing software designed to streamline 3D printing, validation, ordering, and manufacturing. They are also a great partner on Automation Alley's Project Diamond, where we use 3 Your Mind software to connect users of 3D printing with their end customers and automate fabrication process. So today we're really going to be discussing and diving into the consequences of siloed data and provide a meta-analysis of the software sector as it relates to additive manufacturing and Industry 4.0. Specifically, we'll touch on the role of software in Industry 4.0, methods for navigating those data silo challenges, and we're really going to try to gain a contextual understanding of I4O concepts and practice, specifically through Automation Alley's Project Diamond. So before we dive too deep into details, I do want to let you know you can use the Q&A function at the bottom of our screen to ask questions at any point throughout the presentation. We will also have some time at the end, so feel free to text those at any point. And lastly, I'd like to welcome our speaker, Alexander Dondo. He is the Managing Director of 3 Your Mind in North America, a specialist in workflow software for 3D printing. Alexander has worked for his entire career in digital transformation in industrial operations. Prior to 3 Your Mind, he was an advisor to CEOs and COOs of major industrial firms regarding Industry 4.0, and for the past 4 years, he's helped both large and small businesses to use digital tools to adopt additive manufacturing. So thank you everybody for joining us, and the floor is yours.
Thank you very much, Alison. Hi, everyone. Thank you for hosting that. I'm very happy to be here and discuss a little bit about 3 Your Mind. The big word of Industry 4.0, trying to kind of like hone in the meanings, and especially when it comes to software, and try to debunk a couple of myths about that, and try to give you some highlights. I will share my screen right away. Here we go. All right. So just before we start, I'd like to introduce a little bit the objective for me during this meeting. Basically, the first thing I want to say is that what is very important is that we basically, I want to stress on the fact that we need to get into Industry 4.0, meaning basically digitization of manufacturing and supply chain. That's a very important part of what's happening in the world of manufacturing, in the world of digital. And I want to prove that we need to embrace that transformation in manufacturing, especially. And I will focus specifically on additive manufacturing, because we are a specialist in additive manufacturing. So I'm going to stress on that specifically. I want to prove as well that I want to make a point about the fact that the traditional approach of software is not sufficient enough. And we're talking about silo of data, and the fact that the agility of the existing legacy software is not exactly at the level needed for the advanced manufacturing that is coming. And I want to explain why. And there's a paradox here. That is that it's not because of like the multiplicity of applications that are available, software applications for ERP, manufacturing execution system, CRM, product lifecycle management, which are like kind of like the standard of software that we see at Oracle, SAP, and so on. It's not because there are multiplicity of this application that there is siloing. The siloing is actually, and this is the point I want to make, coming from this big monolithic approach of software that is the legacy software approach that I was mentioning. And then I'll touch a little bit on what we're doing with Automation Alley in the Project Diamond and show you by the example how do we entail this digital transformation. So 3Your is a specialist. 3Your is a specialist in software for additive manufacturing. Originally we come from Berlin, Germany, and I started the company here in the US, in Michigan, and in Novi, to be precise, in Oakland County. And we are specialists, and this is what we believe in. You'll see that I'll touch on that. We are entering a world in Industry 4.0 where software specialists will have the ground and will need to be used compared to this big, transversal monolithic type of ERP that we are using in companies nowadays, either in large enterprise or in smaller SMEs. So 3Your is approximately 50 employees. You can call us a startup or a scale up. We have like 7 years of existence until now. We are venture funded, and we have customer pretty much on every continent. And we have seen a lot of growth since the time we were at the accelerator of Stanford, the Start Accelerator. We have seen a lot of growth in the world of Industry 4.0 and manufacturing. And I wanna show you the what we see. We are, like Alison said, we are part of the foundation member of Automation Alley, but also part of the Project Diamond as the platform that tied together the whole workflow for production, from order intake to basically the process control on the shop floors. And I will show you a little bit how it looks after that. Before getting into the depth of the topic, I want to just give you a glimpse over what we have. I want to touch in that conversation a lot on how important it is to have an approach, ecosystem approach of software in advanced manufacturing in Industry 4.0. And here, 3Your position itself as a specialist, of course. I have to support my company as well, but this is our vision, right? So the idea is that we provide a software that is dedicated to additive manufacturing, that entail the processes of additive manufacturing, the agility needed in additive manufacturing, as well as the specific features for 3 main components that are for us the most important when it comes to having operations and efficient operations for 3D printing, industrial 3D printing, which is helping companies qualify their parts, qualify the material, qualify the machines, orchestrate demand management. In the case of Automation Alley, the concept with Project Diamond is to go into what we call distributed manufacturing and to include many companies from the county into a big industrial program or industrial community. This is what we enable as well, making it possible to orchestrate and manage a supplier network, a distributed supplier network, and manufacturer, of course, to automate the process on the shop floor. In additive manufacturing, the fabrication process is important, as well as the post-processing, which can represent 50% of the work. When it's finished, it's never finished with 3D printing. So, this is the third component that we provide. So, for me, it's very important here to, advocate for this change and to share my experience and that change that is coming, the vision that we have in a world where we need to adopt another angle to digital transformation. There are two things about digital transformation. There is the vision and the paradigm we are in, and then there's the speed, right? So how fast companies are going into that change. And interestingly enough, there are drivers to change. And of course, there is a lot of drivers, like internally in companies. The CEO is having his vision, the CTO is having his vision or her vision, the CIO has her or his vision as well. But what we've seen recently, and it's even almost not a joke, COVID-19 has been an excellent factor also that we've seen for digital transformation. We've seen a lot of need to get into more automated, to automate more, like a lot of processes that used to be done very manually before, because of the remote work needed to happen during the crisis. And this little joke is also actually a little bit of a reality. I'll touch on that later on, but it's interesting to see that now more and more companies realize that we need to get into that Industry 4.0 paradigm, meaning that we need to have software and we need to collect data. First of all, we need to automate that collection of data. We need to automate the processes more. We need to give more agility to workers and ability to work remote, even for the most heavy industrial processes. Why do we need to get into Industry 4.0? Why do we need, what's the urgency to get into that data world? I want to take a quick example that is actually from Stephen Hawking's. And I find it very interesting. It could look a little bit trivial, but when you think about, I'll take the example of the human DNA, which is one of the primary database that exist in the world, right? Since millions of years already. Human DNA is approximately 100 bits. A bit is, as you know, an answer of yes, no question. 100 million bits is the DNA, and this is basically the database of humanity, right? Today, it's progressing pretty much at the level of maybe 1 bit every year, not much. In comparison, it's approximately actually around a paperback novel would be approximately 2 million bits. So basically, our DNA equals 50 Harry Potter books, although the quality of Harry Potter books could be debatable. But it means also, if you take a national library, it's about 5 million books. So basically, 10 trillion bits if you take all the books, all the data within the books. So basically, all the books in the world represent more than 100,000 more data than our own DNA. And this is just talking about the current state, and this information is always growing. It's only talking about books, and we don't even talk about the internet. That means that the information, the external information, the external record of humanity is more important than the internal record, right? So we grow faster outside of our bodies than inside our bodies. And this is very important. It means that there is an enormous potential of growth in terms of data that is most of the time not well recorded, not recorded basically, or not well recorded. And when it comes to manufacturing, it's even worse, because if you look at the different analyses, manufacturing is the industry that produces the most data by a lot. compared to the others. We think a lot about social media, of the internet, and so on, but it's actually manufacturing in general, and additive manufacturing will touch on that. That yields the most data. So if you take that example here, just to give you a sense of what it means, this is basically, we're talking about petabyte. So it's basically 1 petabyte is 1 million gigabytes. So we're talking about enormous amount of data that could be produced, that are produced and not even tapped into. It's kind of the unknown world. It's of manufacturing, is that all this data that we're creating. If you just mind that 1 petabyte is basically 11,000 4K movies, which represent about 2.5 years of binge watching. So even if you're a big fan of movie, I think it's a lot, but it shows that basically manufacturing is creating a lot of data, basically almost 2,000 times more than 11,000 4K movies. So a year. So it's crazy. And of course, all the data is not absolutely relevant to collect. But if you even take 5 to 10% of this, I think we're far from that point. So there's an immense opportunity cost not to collect this data and not to tap into the potential of using these analytics and using it for continuous improvement. It's especially this point is especially true for AM. AM is the most data intensive manufacturing technology as of today. Although some people might have argument against that, I think it's arguably one of the most advanced technology for in terms of data generation, but also because it's a complex technology that. Let's say if we take, for example, CNC, you have of course, the axis, you have the path, you have the speed, that are parameters for production, use 3D design as well. But when it comes to additive manufacturing, on top of that, you also have laser intensity when we talk about powder bed fusion, for instance, or SLS, layer properties, powder transformation, you have also chamber pressure, and many other parameters that you need to take into account. So basically, if you want to take an example, it's like you go from a very deterministic world of conventional manufacturing, where things are very, very much dependent and predictable, very much to a certain extent, but at least standardized. And you go to a new world of manufacturing, of advanced manufacturing, which is AM. And it's a little bit like coming from the classic Newtonian physics to the quantum physics, where you go from a deterministic approach to a more stochastic, more statistical world. So if you take additive manufacturing, which is more about statistic, there's no certainty yet. And this is also one of the pitfalls still of additive manufacturing. But it's also one of the beauties that most of the work we do is not really yet very, very well predictable. We're still learning a lot, but there is so much data that we can use this data to make our processes more predictable. And guess what? Additive manufacturing is actually getting, or industrial 3D printing, I know we refer to that as AM, is getting more and more into the production world. And we see that happening slowly in some occasions, but surely, and especially lately, the last couple of years, not only in terms of the new technology that came in the market, but also because of all the merger happening in the market and the value that the companies in the AI market got in terms of growth. So if we take in terms of adoption, we have basically an average of a 10 time factor 10 in terms of adoption of end part production for AM. AM, as you know, was like mainly used 70 till between 60 to 70% of the time used for prototyping and functional prototyping. It's still a big market for AM because of the freedom of design, because of the speed, and so forth. But now we see more and more use cases for production, and that's also the goal of Automation Alley, is to promote that that trend and help Michigan companies basically adopt industrial 3D printing for production. This trend is happening basically in every country, very much in the US, in Germany as well, as one of the most advanced country in Europe. but pretty much all over the world. And there is a race here to really be able to entail that move of additive manufacturing and that readiness of additive manufacturing technology toward end production. In terms of value, basically the 3D printing market will be, and this is a projection from the Waller's report, which is one of the references for additive manufacturing forecasts and studies. We estimate that approximately 1/7 of the manufacturing market will be additive manufacturing by 2029. And there is approximately, depending on studies, between 30 to 40% compound annual growth for additive manufacturing. So the market is growing a lot. The value of the market is growing a lot. So there is a lot of money potential also for companies to get into that and to adopt both, in that case, the hardware and the software paradigm and technologies of additive manufacturing. Additive manufacturing, as I said, is so manufacturing in general is producing a lot of data, specifically additive manufacturing. And here I want to deep dive a little bit more on why additive manufacturing is so complex. One way to explain this is that when you think just about planning production and scheduling production, there is something that we call nesting in additive manufacturing, which is basically putting all the part coming from different customer into one build. So if you think about a shop floor of additive manufacturing, let's say one of the most advanced company in Michigan is Ford in terms of additive manufacturing, and they have an amazing center which is named the Advanced Manufacturing Center, AMC, in Redford. They have more than 30 different print technology in the shop floor. When you take an order, you take basically dozens of different parameters that tie to the customer request, to the 3D design, the material, the processes, and so on. And all these different parts are going sometimes in the same build, right? So you're nesting them in the same build and orienting them toward the right technology. So the complexity in the shop floor, 3D printing shop floor, is very important because you always have to lead this part to the right location, to the right printers that has the right parameters, and so on. So when you think about it, and this is just about the build, then once you have defined the nesting of a job, you have done the data preparation, then you get into the production itself, the job. Then you have the post-processing, which is another route. And after the post-processing, you have the quality control. And then, of course, all of this has to be tied together in one management vision. So being able to manage the complexity of shop floor and all the data that are produced within that process is key. It's key for the competitivity and it's key for adoption of these new methodologies. So it means that a shop floor for additive manufacturing is both very agile and full of complexity, and needs also software technologies that come from classic workflows, specific workflows, but also connectivity through IoT, for instance. IoT is one of the most important challenges that need to be solved now in additive manufacturing, creating a data schema with all these different machines. We're talking about Ford, they have a lot of technologies. How do you tie all these technologies together in one data schema? How do you foster interoperability between the machine? How you make sure you can do analytics throughout that is a very important next step for Industry 4.0. Basically, it's a little bit like a good example would be scheduling planes. When you schedule basically a nested build in additive manufacturing, it has sometimes, and I'm just talking about scheduling and production planning. It looks a little bit like a very busy airport, and this requires a lot of intelligence, being able to optimize depending on a lot of factors throughout time. And this agility comes with challenges. When we deep dive a bit more into the process of AM, and here also on the challenge of AM, we see that, for example, there are three main components that brings some challenges for current processes without optimization. First of all, the need for qualification, and usually qualification engineers spend months working into what we call the applications for additive manufacturing. They analyze thousands of data in sometimes not very structured or systematic way with not the right tools. Then there is the demand management. I was talking about the suppliers, and then it takes up to a week to get a quote from a supplier in additive manufacturing, because also estimating the cost of additive manufacturing is not always as simple as it could be in other technologies. And then of course you need to manufacture the part that you have ordered, the build, the data preparation that needs to be done for the build, the planning, the quality control, usually is done in software tools that are not adapted, and especially Excel sheets, for instance, or in very manual processes, and this leads usually to poor data visibility. So basically, this technology of additive manufacturing is bringing a lot of potential, but has limitation in terms of tools that enable the use of data throughout this processes. And in general, even the big question is data continuity throughout these processes. You have these three big processes. How do you make sure that the data that are created within the qualification process will be followed also within the manufacturing process? The problem is that most of the software in the state of the art today, the old legacy software, legacy management systems are hurting production potential because of the lack of agility and the lack of continuity. This basically what we see today, before getting into kind of like the new paradigm of software that I want to talk about, we see more like mostly in big enterprise and small enterprise, monolithic do-it-all system. And this system are stifling productivity, and for many reasons, and I want to touch on three of the main. One is too much reliance on manual data entry. So they're not built to support a wide range of equipments and system, hardware and software, on the shop floor, and the complexity I was describing, for instance, with a shop floor with 30 different technologies. They are kind of like what we could call jack of all trade and master of none. That's the second point. Basically, as advanced manufacturing is highly complex, a solution that could manage everything would be the holy grail, but it's quite unrealistic. So, and that's my point as well, to consider more specific software and an ecosystem of specific software for the different manufacturing technology. And the third point about this legacy system is they're prohibitive in terms of cost and basically difficult to deploy. So adding insult to injury, this old ERP manufacturing execution
It looks like we might have lost Alex due to some internet difficulties. So I'm just going to jump in really quick to see if we can get him back. But I also do want to remind everybody that you can ask questions in the Q&A at any point. So if there's any questions you have regarding his presentation, we also are going to be able to have some time when he's done. So if you can just bear with us for the moment, we are going to see if we can get him back. And thank you so much for being here. All right, it looks like we do have him back. He's just connecting with the audio and video.
Sorry about that.
No
I'm probably
problem.
using a legacy system for this presentation. My computer crashed. So I'm right back. Sorry, everyone, for that. Here we go. And you should be able to see my screen again. Maybe, I don't know if there are questions that arose in the meantime, but I could answer them if needed. Can you still hear me?
Yes, we can. You're all set and we can see your screen as well.
All right. Alison, can you turn off my video, or should I? Might be the reason why. Crashed. Hello. Can you hear me?
Yes.
All right. I am right back. Okay, so I was talking about legacy system, which I believe is what's happening in my computer. But here, getting back to what I was talking about, legacy systems. So I was talking about like cost prohibitive systems, the classic ERP, what we call monolithic. So this big software legacy systems that basically do pretty much everything in terms of enterprise resource planning, manufacturing execution systems. They're not adapted to the world I was describing before. What we see as most the way forward is basically to take different components of this legacy system. It doesn't mean that everything related to ERP, everything related to product lifecycle management, PLM, manufacturing execution system, MES, don't exist anymore. It's not the death of this type of functionality, but it means that we need to take that functionalities to break it down into specialist software, functional specialist software. This for a better way to mirror the complexity of advanced manufacturing, and especially additive manufacturing, for instance. In general, I would say that the statement would be that manufacturers would need to be free to build their own technology stack with the tool they need, not the one that their big ERP monolithic provider has chosen for them, right? So we need to allow manufacturers to focus on specialized area, and then with that, drive their productivity and their competitiveness. It's about that, right? It's about the competitiveness. If you're using the same monolithic software as your competitor, you'll not be able to really shape your processes or create competitive advantage. The IP today in additive manufacturing, for example, is even more complex than IP before, not only because you have the design IP when you produce a part, when you're doing contract manufacturing, but also because there is the IP of the parameter set on your machine that is specifically different from one user to another. The way you use the machine, the way you use your material, the way your parameter strategy is very important as well. So there's the IP today in advanced manufacturing and additive manufacturing is twofold, which makes it even more complicated. So you need to be able to entail all the different aspects of your manufacturing with the right ecosystem that you put together. So the way forward is basically selecting SaaS solutions, so solutions that will be maintained in an efficient way with open APIs. SaaS doesn't mean necessarily that your software should be on the cloud, right? There's many ways of having your solutions, but SaaS means also a way to maintaining in a more efficient way the updates, the bug fixes of your applications. And the idea is that if you want to create this ecosystem, if CIOs want to create their ecosystem, they need to choose the right software specialist, but especially focus on an open API strategy, right? This is very important. Interoperability is key here and not provided by this legacy software I was talking about, but needs to be the way forward when it comes to selecting the right technology for shop floors. So again, CIOs are more and more focusing in creating this ecosystem approach and gain in terms of interoperability. That means a lot of probably a bit more work than just buying the classic SAP software. That means a little bit of strategizing on what are the best applications depending on my workflow and depending on my positioning in the market. But this is key. Now there's still some challenge to be solved for adoption of this new technology, like additive manufacturing, for instance, and the software that goes with it. First of all, it's the skill gap. I read a recent study from Deloitte that says that 80% of manufacturers in the US can fill job openings, and it's going to be even more in the future. And I'm going to talk about that real quick. SMEs also are often thinking twice in terms of when they want to invest in Industry 4.0, of course, because sometimes their ROI is not very clear. It's both a qualitative and quantitative ROI. And also because there is a lack of visibility on standards. And also, like we've said it for additive manufacturing, it's a growing market. So the standards are being built. But it doesn't mean that we cannot start working together on that standards. So, and finally, of course, there's data security. I was talking about EIP. Data security Industry 4.0 is also a big challenge to solve. So we ought to go together hand in hand and solving hardware company, software company, solving these challenges together. Now there is a hope. When I was talking about the skill gap, digital transformation can solve that problem. Actually, the skill gap is even accelerating the adoption of digital manufacturing technology and the digital transformation, because technology and automation are here to fill this gap of knowledge in advanced manufacturing in AM. And the fact that monolithic systems require that much maintenance, that many people to maintain it and so on, will not facilitate that and will not help the skill gap. And now, on top of that, we've seen the importance, like with the skill gap, also of the supply chain recently and the disruption of the supply chain, the need to reinvent our supply chain. So we'll need, we have like a lot of challenges ahead of us to make our economy more agile, and one could say, of course, sustainable, is to be able to have the right amount of technology, the right amount of skilled worker, and a good vision for our supply chain. And here, I'm sure there's a lot of SME people here. The role of SME will be very important.
Hey, Alex, are you able to share your screen again?
Yes, I was actually sharing. You didn't see it?
It looks like we can't see it. So as you figure that out, we did get a question.
Okay.
So I'll ask that, and then, oh, perfect. We can see your screen now. Awesome. And then we did get a really good question. And that was, what is the project diamond that you mentioned?
I will touch on that real quick.
Perfect.
And just, so I was talking about this 4 challenges for those who didn't see, and touching about having all the functionalities of ERP, PLM, and MES stored in one platform, but a specialist platform. And that's, by the way, this is going to answer a little bit of the question about Automation Alley and Project Diamond, is that Project Diamond is vision by Automation Alley of a platform, an advanced manufacturing platform that entails different components of software and hardware connected together to address the vision of creating a distributed manufacturing network in Michigan, in the Oakland County as first, with a lot of 3D printers. So basically, we have like a bit more than 300 printers, and it's going to grow, that are all connected together. And also the platform that is the digital twin of this production environment. And as I was saying, the software component that compose that platform are specialist components. So basically, Automation Alley at this ecosystem approach, saying, hey, we need the best specialist software in the different areas of manufacturing, and put it together. And the central objectives here for Automation Alley and ourselves is a maximum interoperability amongst these different software pieces. I was then talking about the skill gap, and the skill gap is what is gonna accelerate adoption. Actually, it's gonna be a challenge, but it's gonna be accelerating adoption of digital processes, because automation will be able to bridge that gap in some occasions, and this is what we start seeing. To get more into the project diamond, and I wanna here, I will have to share something different, but I want to show you real quick what the interface of this, the project diamond would look like for someone who wants to get into production for additive manufacturing. So mind that project diamond is hundreds and hundreds of companies in Michigan having 3D printers provided by Automation Alley, and anyone in Michigan and elsewhere could go in the platform, look at this supplier, and know exactly what they need to do when to get into production, right? So I will stop sharing quick and show my screen again with the right screen. But basically, I will show you what's the user story here of this project diamond. My screen is here. So when you go in Project Diamond, you have like a login, and I will share my contact, but you can also reach to Automation Alley to learn more about that. But basically, when you get into the platform and you want to order a part in the ecosystem, you get into this interface. And this type of interface, by the way, is way different than the monolithic software I was talking about, like the legacy software. This is an interface dedicated to AM, and to really be able to entail the requirements of application engineers. I'm going to do it quick, but basically you can upload 3D files. The 3D file will be analyzed automatically by the platform, optimized, right, to be ready for additive manufacturing, and then checked against the capacities of the different suppliers of the platform. So you can see, for example, here that it's optimizing. We're transforming the STL to be ready to be printed. So basically here in dozens of seconds, we're basically doing the work that could be up to 25 minutes for just one design. And as you can see here on the right, well, the last file is loading. You can see all the technology that can produce this part, and also automated pricing, right? Or manual pricing as requested here. The platform is still, by the way, in the final mode of configuration. But here you can see also the 3D design and so on. So again, it's about like, this is a specialist workflow, right? Of course, the platform of Project Diamond will have an ambition also to entail other technologies. But when it comes to additive manufacturing, Project Diamond has entailed our technology to be able to give feedback on and information about how to produce this part in additive manufacturing. Here you can see all the technologies that can produce it. Let's say Markforged, which is one of the partners of the project. You can see that when you select this platform, you can see that there are different suppliers that can provide that part. And once you select one, for example, this one, you also get a printability feedback, because of course, additive manufacturing is not as simple as you can print everything, but you also have like some designs that cannot fit into the build or for the material that is required. So the software is automatically giving a feedback and avoiding a lot of back and forth, and giving also education to users on what could be printed. Once you have that, you select your post-processing, select the due date for the part, upload attachment if needed. Basically, you can also replicate that for the other one, and then basically order your part. And then you will have the process directly with your supplier and all the information you need to be able to be ready to print, the cost, the print parameters, the quality required, the certification needed, and so on. So really, the goal of this platform is twofold. It's kind of like an Amazon of additive manufacturing, manufacturing as a service vision, so to speak. But at the same time, it's also the Google map of additive manufacturing, because through this software, you'll be able to know, once you have input some requirements and specification, what's the best way to produce your part to achieve lower cost, better lead times with additive manufacturing. Basically answering the question, how do I make additive manufacturing an asset for me rather than a cost? And how can I basically leverage the potential of additive manufacturing within this? So that's a quick example. I think quickly enough, you all will be able to access that. And I think it's a very exciting project, unique in the world, and that has a lot of ambition. And I will be very happy to see more and more people jumping in this adventure. Thank you very much.
Perfect. Thank you. That was a really good description of Project Diamond, and it was nice to see specific examples. So we'll open up the floor for Q&A right now. If anybody has any questions, you can type them right in that chat, but I'll just start us off for a second. I know that a major challenge of additive manufacturing is to identify the right business cases. So through your mind, do you help your customers to define these? Is it what is going on with them currently? How does that work for you guys?
So it's a good question. I touched a little bit on that when I'm talking about the Google map of additive manufacturing. Part of the component that will be accessible also in the Diamond project is being able to populate specification. And this could be not even like for part that were thought for additive manufacturing, part that you have in your inventories, data that you have in some database, but also on shelves, basically on warehouses and so on. You can populate the software in many ways with a wide range of data, what we call like 3D file and so on, PDFs, photos as well as what we call metadata, CSV, whatnot, and then get a feedback on all these inventories that can upload. What are the best parts to be produced? What are the best parts to be produced with AM, and what are the best technologies? So to help the adoption of additive manufacturing, again, one way software can help is also in helping guiding people, guiding professional through what are the right way to get started in AM, and the right way also to do pre-qualification, qualification of new parts. And this will be something we help the user with in Diamond as well.
Perfect. And we have I have a couple more questions that came in, so I'll just start from the top. The first one is your software available on premise?
Yes, the answer is yes, and pretty much any type of premises. We are working with the US Navy, for instance, and the US Marine Corps. So DoD has very specific security requirements that we can abide with too. So yeah, on-premise is definitely something that we do.
Perfect. Getting a little more specific into Project Diamond, the question is, what is Through Your Mind's role in Project Diamond? And then what is the overall objective of Project Diamond?
So great question. The overall objective of Project Diamond, and here I don't want to speak as the main representative of automation of Project Diamond, because we are the backbone of the AM software workflow. And the Project Diamond is even bigger than that, I think, at some point. But to answer the question is that the project is basically to First of all, the goal is to enable the vision of Industry 4.0 and distributed manufacturing. That's the top-down vision. So it's big words, but it's important. As I've shown you, Industry 4.0 is about tackling the problem of all this unseen and unused data that we're creating every day. So like making it possible for small, medium enterprise, but also bigger enterprise to tap into the potential of the data they create, and also leverage new technologies like additive manufacturing in an easy way, right? So that's the other aspect of automation is adoption, making sure that people understand and professionals understand the advantage of advanced manufacturing, of 3D printing, and basically adopt it in a very simple way and at low cost, by the way. And that's kind of the goal. The first question was about what's the role of 3Your-Mind. 3Your-Mind is the software that will take you from A to Z in the additive manufacturing process. From part requirement for part pre-qualification, you will have access to and you will be able to create your own AM-ready digital inventory up to basically post-processing and delivery. So we entail that process specifically for AM and be able to connect with our software all the locations, right? So you'll be, if a user of Project Diamond wants to use the interface of 3Your-Mind to sell their own capacities in AM with Project Diamond, they can do it. So basically it will be a workflow for you, like the users, let's say, and the end customer, the buyers of 3D printed part to communicate together from pre-qualification, like I said, to part delivery and part production, part delivery.
Perfect, thank you. The next one is, are there geographical limitations on companies participating in Project Diamond? I'm assuming that's tailored towards your software and what it can do.
There's two aspects of geographies. One is, I mean, there are two types of users. The user who is ordering part that will be able to access the network of production partners of Automation Alley and Project Diamond. I think there's no limitation for that, I'm pretty sure. For the users, the companies that can participate as producers with a printer to the Automation Alley project, it is so far entailed in Michigan counties. But the goal of this project is to be rolled out once the blueprint is working, and we have made amazing progresses to make that platform functional. The goal is basically to roll out this concept pretty much everywhere. So at the end of the day, they will know there will be no limitation. But in general, I think to answer this question even more accurately, I'll suggest that you also get in touch with Automation Alley people.
Yeah, and we can send some information, especially with these specific Project Diamond questions. We have a whole website for it, so we'll send those couple people just a really good overview and some contact information to dive into those very specific questions. The next one is, does or will the system offer design and design modification services?
So part of the ecosystem, and it's a good question because now it touches on the ecosystem interoperability. The software 3Your-Mind doesn't provide like design optimization, let's say, or redesign functionalities, but we connect through open APIs to other technologies. One is Trinco, for example. And the vision, the ecosystem vision of Automation Alley with Project Diamond is to be able to connect together this different piece of software, especially this piece of software with this API connectivity. API meaning the application interface. This is kind of like what makes, let's say, the Google apps work together within the Google environment. It's kind of the vision of Automation Alley together, is that having some apps that are specialists in their domain working with other apps with seamless transmission of data. And so the answer is yes, it will be possible.
It looks like we have two more questions. So if anybody else has questions, now would be the time. I'm going to switch up the order. So is 3Your-Mind on the cloud via subscription?
Yes. So basically, the software of 3Your-Mind is one of the backbone of the Project Diamond. but if you're interested in 3 Mind, you could have it for your own project, right? And Project Diamond is also willing to connect users, professional with the technology part of their ecosystem, to also discuss how they could use this technology for a more specific project or programs or their own production shop floor use, and basically use our software to tailor this to their processes.
The next one is, what are the main process steps that you optimize, and can you share numbers?
So there, and it's a good point. I can go back to the 3 steps I was talking about earlier. I think you see my screen, right?
Yes.
Okay. So here, these are the main process steps that entail the most complexity today in conventional processes, like or with legacy system or with manual processes. First, to qualify, it's a big hurdle to be able to entail all the data and data points of the data preparation phases and the post-print collection of data to qualify a part, right? So engineers spend a lot of time into qualifying parts, and it's very costly for additive manufacturing. Here, we can reduce the qualification time with our piece of software that is doing that, which is a PLM piece of software. We can basically reduce by 70% of the time for qualification, thanks to pre-qualification algorithm. And we help also to identify 5 times more use cases basically here. Demand management, like I said, like if you want to get a quote for additive manufacturing, can take some time, but a lot of back and forth, and also some inaccuracy could come. Here we can reduce by 85% the time of ordering per order, right? So which could be substantial. And then manufacturing, I think one of the big problems is machine utilization. Of course, also machine repeatability, but in terms of number, this is easier to tackle. Machine utilization could be quite low in additive manufacturing and could be a important factor when it comes to competitiveness. And we can help have better visibility in the process I was describing, especially when we talk about nesting, scheduling, and so on, making sure that we know what order should go where, the Google Map aspect of manufacturing. This we can we can improve the utilization rate by 25% approximately.
And I will say that feeds nicely into the last question. You've talked about a few customer examples and use cases, and that's exactly the last question. Do you have some customer examples, and maybe do you have any resources, your website or anything like that, where they can read more too?
Yes, on the website, you can go to 3yourmind.com, which is here. And you'll see a lot of things about our software and our vision, a little bit about our customer as well. And the other thing about our customers, we have big automotive customers that have a lot of printers and a big vision for advanced manufacturing, not too far from where you guys are located. And we have also customer like J&J, for instance. J&J was, during the pandemic, producing a lot of prototype toolings and parts for PPE, which is the protective equipment for health personnel. They were producing a lot of respirator device to compensate the shortage of traditional injection supply chain. And they are using our software actually to get this order in, see how additive manufacturing can ensure this. So they would take a lot of this design, the specification during the crisis, get a lot of order. It's crazy the amount of order that went through our software for J&J at the time. They're using it for, in sites in Massachusetts. And they basically use our software to know how much it will cost, what technology can produce this, what is the way to produce and qualify that, and then basically run the production. So it was a really big help at the time, because actually such a software as this one is actually makes sense when you have a lot of complexity, high volume, high variation of demand throughout the time. Basically all the component of the agility of that provides additive manufacturing, then our software and the agility of our software is very important, because we can really until that and give the flexibility that the users wants to have on their shop floor. And basically also collect data, being able to do analytics afterwards and see what were the most used technology, what are the most used material, what are the results of each printer throughout time, and improve continuously their parameter strategy, the material supply strategy, and so on.
That's perfect. Thank you so much. And I think the website is a perfect example of all the other case studies and things you can see. If you have any more questions or want to learn more about Through Your Mind, feel free to go to the website, as well as we do have all of Alexander's contact information, so you can send him any questions. I know there was a lot of questions about Project Diamond, so we'll be sure to send out some information on that too, and really help people to understand the major role Through Your Mind is playing in Project Diamond. But if there are no questions, I'll wrap it up. Thank you everybody for attending today. Don't forget, this was recorded, so it'll be on our YouTube channel if you want to share it or learn from it some more. And thank you so much for joining us. Be sure to register for Integrate. We'll have a humongous expo booth on Project Diamond, and you can also see Through Your Mind there. So thank you so much and have a great day.
Thanks a lot for having me.